I'm gonna go ahead and get started here. Okay, so here are the live notes for PreCal lesson 2 of this week. So a couple things I want to note on just because they've come up since then is that there is going to be a day where they're going to be giving out school supplies. So if you or anyone you know might be in need of something, here's some information on that they'll be giving out on the 8th. So tomorrow, at the 7 different meal locations from 11:30 to 1 p.m. So spread the word if you know of anybody that needs anything, okay? Yeah. So today what we're going to cover is solving rational equations. Like yesterday's material, there is an IXL activity, so there's additional information here. Again, reach out to me if you can't find your login information. We're going to go over the notes. Here's a teacher copy. We're not going to cover all of the problems. So, yeah. Okay. All right. So solving a rational equation, we're mostly going to stick with method 1 type problems. Ones that involve using cross multiplication to solve them. Friendly reminder that we always do want to check our solutions, make sure there's no extraneous solutions. And by an extraneous solution for a rational function, that would be something that would cause you to divide by 0. So for example, number 1 here, the value of x that would make this first denominator 0 would be positive 6, and the second denominator is 0. So if we get positive 6 or 0 out of this equation, those can't be the answer because they were undefined for the original function. Okay. Alright, so yeah, so when you've got like a fraction equals fraction situation, we can use cross multiplication to solve these things. So cross multiplying, we'll get 7x is equal to 4 times x minus 6. We'll distribute the 4. And then it becomes well, in this case, a linear equation. Since we only have x to the first power, it is possible to get quadratics that would involve factoring to solve. So we'll just simply solve this for x. So subtracting over the 4x will get us down to 3x equals a negative 24, and then dividing by 3 will get us negative 8. Okay. Alright, problem 2, same idea. We're going to cross multiply. Can't read it. 3 times 2a plus 1 equal to 7 times a minus 8. Distribute the 3 and the 7 respectfully. Seven times 8. Well, 7 times 7 is 49, and then I add another 7 will put me at 56. Okay, and then I solve for a. So I'm going to subtract the 6a from the left-hand side over to the right-hand side, and I'm going to add 56 onto the left-hand side. So it's going to get me 59 is equal to a. Yeah? Yeah. Okay. I didn't check for extraneous solutions here on either one of these. So the first problem with this states is that x cannot be positive 6 or 0. And the second one where we have x cannot be a positive 8, or let's see what value would make 2a plus 1 equals 0. Negative 1/2. And the way that I'm getting that negative 1/2 is essentially setting that to equal to 0 and solving for x, or a, the variable. Okay. Alright, so both of those fell out to be linear. So the next ones fell out to be quadratics. Alright, so cross multiply, we'll get r squared is equal to 4r minus 4. So anytime that you see that you have a variable squared indicating that you have a quadratic, the motivation of solving changes. So to solve a quadratic, we need to get everything over to one side and then attempt to factor. It's going to be a lot easier if you have a positive r squared value. So for that reason, I'm going to move everything over to the left-hand side. And then I'll just factor this. So let's see. Numbers that multiply to be positive 4 that add up to be a negative 4. So that'll be a negative 2 and a negative 2. So I have r minus 2. R minus 2 is equal to 0. Solving these, very similar to what we did with solving polynomials 2 weeks ago. This indicates that we have a double solution at positive 2. So then I double check to make sure that I don't have to eliminate any of them. So up at the top, let's see, r cannot be positive 1 or 0. So we're good there. One moment. My apologies there. Okay. Alright, number 4 here, cross multiply these two things together. So m plus 3 times m minus 2 is equal to 24. So I'm going to FOIL out, distribute out those two polynomials. Let's see, we'll get m squared minus 2m plus 3m minus 6. Don't forget those middle terms. Equals a negative 24. I'm going to combine like terms. I do again have a quadratic, so I'm going to move everything over to where the variable squared is. So in this case, the left-hand side. M squared plus m. So 24 minus 6. So take away 4 gets me down to 20. Take away 2 more, 18. Okay, and then we're going to go from 18 to 1. Right? One, 18, 2, 9, 3, 6. Un momento, por favor. Make sure I'm not doing something silly here. Oh, it's a positive 24. Doi. Give it a minute. There we go. Okay. I see what happened. When I went from this line to this line, my 24 became negative. That changes things. It's going to be 30, and 30 to 1 is... That's doable. I was like, no, I don't want to use quadratic formula. And what is that, like 5 and 6, and make it a... What am I doing wrong still? It's a negative 30. Okay. Good morning. My side is being silly and is not showing me everything now. Quite fun. There we go. So let's see, yeah, we're going to use negative 5 and positive 6. So negative 5, positive 6 equal to 0. So our solutions are at positive 5 and negative 6. Then I double check the beginning here. So this says that m cannot be a positive 2. And we're good. We didn't get positive 2s either one. All right, moving on. Pow. We'll just do these last two, and that'll be it. So let's see, that's going to give me y squared plus 5y is equal to 3y plus 24. So moving everything over, hopefully correctly this time. Okay, yes, yes, okay. And then 24, a negative 24 down to 2. See, 124, 2, 12, 3, 6, no, 3, 8, 4, 6. Okay. Change your signs, solving for the variable. Double checking our extraneous solutions here. All this says is that y can't be negative 5. Okay, so we don't have to eliminate any of them. And last one. 2x minus 3, x plus 4 equals 6. 2x squared plus 8x minus 3 minus 3x minus 12 equals 6. Combine all the things. Okay, so this one we have a trinomial and has an a value other than 1, so we either need to use slide divide or box method, whatever your preferred method of factoring is. I think I did some box method on like the solving polynomial stuff, so I'm going to use slide divide on this one just to kind of refresh. So what we do for slide divide is that we slide over the 2 with multiplying it over. So that's going to get us at x squared plus 5x equals minus 32 equals 0. Then we'll go from 32 to 5, negative 32 to 5. So let's see, 132 now, so 2 and 16, not 3, 4 and 8, not 6. I'm supposed to get 5 out of that. Boop. Conference inspiring, I know. This 18 times 2 is 36, not 32. It is hella embarrassing. I will say that. Alright, what? 2 and 18 doing? 3 and, let's see, that would be 10, and then 2 more, so that's 12. 4 and 9. 4 and 9, so I'll make 5. But the thing with slide divide method, Why is it not showing up on the screen now? It doesn't like when I switch back and forth, apparently. We multiplied both things. We multiplied over by 2, so you want to divide by 2 to get it knocked back down, because we can't just simply like willy-nilly like change the numbers around like that. So let me kind of redo this. Okay, so we slide over the 2, multiply by 2. So that changes this to x squared plus 5x minus 36 equals 0. So then we're trying to go from negative 36 down to 5. So that's where we got the 4 and the 9. It was specifically a negative 4. So x minus 4x plus 9. But that initial thing up there of multiplying by 2, we need to undo that. So we're going to divide by 2. And reduce if we can. If we can't, then it slides to the front. So this is going to be x minus 2. And this one, since 9 halves doesn't reduce, the 2 slides back in front. So this tells us that we've got solutions at positive 2 and negative 9 halves. Okay, alright, that was it. I'll be available for the next bit. If you guys have any questions, if you need your login information, anything like that. Okay, toodaloo.